Today I'm playing with focal length of a parabolic antenna for Wi-Fi frequencies, and this is a design that I found online made by a guy, Windsurfer. So you'll find a nice web page and some sort of a video, and he came up with the idea that most of the parabolic antennas or the signal boosters you find on the market are round, and it's true. I've seen some designs like a made in China design. They made a round kind of halves, like a half of the circle. It's like taking a bottle, cutting in a half and mounting in an antenna, because I was really tempted about doing that. And they say, yeah, you may get some results, but the best is use the parabolic design. And I can tell you I installed probably a few hundreds of parabolic satellite dishes for satellite receivers, and also a few satellite transmitters, and I did work with a big large parabolic antenna, so I have an idea how to calculate the focal length and stuff. But when it was about the drone controller, extending the range, I didn't want to spend time designing a parabolic surface and stuff. So since I found this guy, and I'm thankful for his work, I copied his design, and he used sort of file folders, paper like a cardboard. And I thought of using that type of method, but since I had some empty container, like a food container from Costco, I used the bottom, which is made of thin aluminum. And for my experiment, is just good enough. And as you can see, I used. You can use even a, but I tried a milk jug. A gallon milk jug is a bit small for this design, but I've used other type of larger plastic container for this part, and I cut it. It's like you find this information on the internet. Again, credits to that guy, Windsurfer or something like that. And now it was time to test, see some results. But the thing is, I don't have that app to measure RSSI, like receive signal strength levels, and I'm using the signal bars that are coming with a Litchi or a DGA app. But first, I had to work on the shop today for a bit, and first I'm going to show you how I test it with a light source instead of using the antenna, which is your dipole, like that. Instead of using the antenna as a radiating element, I'm going to use a cheap light source. So this is just an experiment. I'm not going to make one of those obnoxious videos like yeah, so if you have to do this, you have to follow my instructions because I'm the best in the YouTube. So I'm not going to make one of those videos. I'm not looking for views. I'm trying to share my findings and maybe help few guys to get a system. So since I'm using one of these dual antenna for my drone, this design is not really good for dual antenna. So it was designed for a Phantom 3 with single antenna, which is kind of right in the middle. But for my remote control, is room for just one. And since I have two antennas for better link, so you have two antennas for the situations when the signal might bounce off the walls or whatever, and the receiver inside or the system inside is picking the best signal. And in my case, if I have the antenna close to this metal, the second antenna close to the metal, it's just wrecking the signal pattern of the second antenna. So there's no point to use this antenna up. Later, I will build two parabolic dishes or antennas, reflectors, to accommodate my design. So I'll get one like that and one like that to accommodate my antenna. But for now, I'm going to experiment this way. So what I did, I modified the antenna, one of the antenna, the dual antenna. So in my case, I have two antennas in one. I have 5.8 gigahertz antenna built in for the radio link, for the telemetry, and like for the controls and joysticks and some data. And that same antenna, there is one of the Wi-Fi link antenna for the IP camera. The same antenna without the 5.8 gigahertz antenna. So for Wi-Fi antenna is the second one. So you will have three cables. Two cable goes to this antenna internally and one cable goes to that antenna. So since I deactivated my 5.8 gigs antenna, I explained in different video was the reason. I thought I don't want to rely, or I don't need to rely much of this on this antenna, so I'm going to point it down. But how you make these antennas to point down, because they are designed to move that much, so you have limited range to fold, to be active, so vertical, and kind of like that. That's it. So what I had to do, I had to take this one apart, right? So took it apart and pull this antenna out. I'm not giving you instructions. This is not a how to do stuff or how to damage your remote control video. It's just sharing some results. So I modified this thing here to allow me to fold the antenna downwards. So I have still I have limited range, so it does not go more than that. I left it that way on purpose, so I can fold it, I can use it vertically the way it's supposed to, or I can fold it down. For the case, I'm going to use my new antenna. So this one is tilted a bit, but it's okay because the way you hold this thing is a bit tilted anyway. So you hold the remote control this way, and now the parabolic antenna is pointing where you want, right? So you just have to be mindful where this one is pointing, and it's not too heavy, is light, so does not put weight on the antenna making it fall. It might, but it's okay for now. And for my testing to see the real performance of this new antenna, I'm going to hold the antenna, the second antenna, which still has the Wi-Fi link for the IP camera. I'm going to hold it pointing this way. So let's see if or maybe a little bit down. So I'll be parallel with my beam. Why? Is because I minimize the effect of this antenna. I just want to measure signals of this antenna, see how far it goes, signal level wise, and all that stuff. So instead of me disconnecting the antenna internally, I could do that, but it's too many times of taking this thing apart, and I don't like it. So I'll have this one pointing parallel to the beam. So the receive antenna on the aircraft, let's say which is generally is vertical. If the aircraft is vertical, it's upside it's flying normally. Then you get a minimum amount of energy coming into this antenna, and from the transmit antenna of the aircraft on the landing gear. Also, this one receive minimal amount of signal. So because of the receiver has a diversity feature, and I explained earlier what it is, diversity, when the device is picking up the strongest signal. Most of the signal is being collected from this antenna, so this will give me the real results of what I'm looking for. So that's kind of a quick design. And once I get the measurements, I note the distance and stuff. Immediately, let's say I keep the drone on the same spot, and I turn this one down. Why? So as you can see, it's not touching this bar, which could affect the reflected power back into the transmitter, not overheating it, but it affects the SWR. It's a parameter that's important to measure the performance of the antenna. So I'll have this one away, so my wavelength of this frequency is larger than this spacing here, so this bar is not going to affect me at all. And these two sticks are still parallel. Okay, so I get like a kind of an active dipole here type. Okay, so it's going to be an interesting experiment. So let me show you with a light, showing you the performance of that guy design, which, like I said, I'm pleased about. And for that, I'll show you on the wall, on that piece of paper, I built a kind of a pattern measurement thing. So normally I want to measure a parallel beam. So I drew two parallel lines. They are a little bit smaller, but if I go far, would be more an accurate result. But because the light I have here is getting hot, it's a car light source. I don't want to do an accurate test to brag about what I did. It's just an idea. So I have the edges of the beam I expect, right? And I'll go maybe almost a meter away, and will give me some information about the beam and the focal point. So before doing that, okay, I'll show you from some distance, let's say a meter. I'll show you, actually you see the focal point is coming from the neon tube from the top. Now let me see if I can, yes, let's stay away from that neon tube light. But my light source is more powerful. So let's see what happens here. So I'm holding the light at some distance, right in the center, and I see the focal point is right here. It's a bit in front of that hole, but I see a nice, almost clear, see? So I'm happy to see that one really concentrated. And I assume that is not where the hole is, because the frequency of the 2.4 gigs is much lower than the light. So the light I'm using, it's almost a white light, and it contains a lot of different frequencies and different wavelengths. So let's try, see if I can use this one. So I'm keeping it parallel to the wall, to my pattern test, and let's see what I'm getting here. Okay, so if I go right where the hole is, see, I'm getting, so now the beam is maximum about here. About here, it's above the hole actually. Let's try the other light. So actually let me turn it. Okay, try now. You see, it's nice and almost parallel when I'm above the hole. So I guess it's a pretty good design. I guess. So I have to see it in the field. That's a better way of measuring. But for now, I thought to share while I'm in the shop, to share my happiness about finding this design. I'm quite sure you can find different ones online, but this was easy, and it took me an hour because I had to cut aluminum. I had to find the bottles, that like a container that I could cut and bend, and all these fine details. But yeah, I'm glad and I'm happy to go tomorrow morning and do my job and then test, because I need some range to measure in a valley and a glacier. So I have an interesting project uh, flying above a glacier, but not far from the ground level, maybe 50 meter above the ground level on the glacier valley. So see how it goes. I need range. Bye bye.